Hello and welcome to Physics. If you're watching this video, you clearly have figured out how to log on to Moodle and are ready to start the summer assignment. First, just let me talk about physics. This is no longer an AP course, meaning this is not the extreme, super beyond challenging GPA buster course it used to be. It used to be for AP Physics, unless you were beyond a math genius, it was beyond hard. Not so much the classwork, it was more the test. The test questions are just super, 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 super hard. For this course, it's going to be a lot easier in terms of how quickly we have to go through material and just the test. I mean, really, the tests are not going to be nearly as hard. What I plan to do is I do plan to use some of the old AP questions of the easier sorts, and then I can throw in some of the harder questions that are going to be on the AP test and use them maybe as bonus questions. Another reason why AP Physics was so hard was just because there was so much memorization. You had to memorize all these different equations, and you really, really, really had to be strong in math because you really had to know how to manipulate a lot of these equations. You really had to know how to do set equations equal to each other and manipulate from there. In this class, I'm going to be a little nice to you. So, for example, this is the equation sheet students got on the AP Physics 1 test. So when they took the test, they were given a set of equations. Now, does this really answer all the questions? Not even close. Does this mean I'm just going to give you all the equations where all you have to do is plug numbers in and chug out an answer? No. So for example, on the very first unit, I will give you these three equations, right here. These are known as the kinematic equations. Now, what's important about them is, even though I gave you the equations, which you no longer have to memorize, but you have to know how to manipulate them. So for example, if I just looked at the very, very first one at the top here, okay, this says final velocity equals the initial velocity plus acceleration times time. That's fine. It's already set up for the final velocity, but what if I want you to solve for time? So you'd have to know how to manipulate that equation to get time by itself. These are the kinds of things you would have to do. Someone asked what physics is like. I like to think of physics as an applied mathematics course. It's basically taking a lot of material you learned in Algebra 1 and applying it into math situations. Another way to think of it, it's a lot of story problems. If I had to relate it to math, I would call it Algebra 1.5. It's kind of in between Algebra 1 and Algebra 2 in terms of material. Big things you really need to know is you really need to know trigonometry. As long as you know how to manipulate equations, how to solve for a variable, which should be pretty simple, and then you know basic trigonometry, which you'll see later in this summer assignment, you'll be okay. Now, I do want to talk a little bit about the website and Moodle. So, let's go to the website. So you'll notice in the summer paper, there's two websites you can go to. You can go directly to osbornescience.com. And on this website, if you had a chance to look, it might still be like this. I don't know if I've updated it since then. It has my Twitter handle, which again, if you have any questions whatsoever, you can ask them on here, as well as I will post any updates in terms of, hey, I have this posted on Moodle, or hey, this assignment's coming up. I'll give deadlines. But this is just a welcome page. The important thing is right here, there's a link to Moodle that you can just click here and go straight to Moodle. Over here on the side, I have different links. Now, these are not updated yet. In fact, if you click the physics one, it will take you to a map of Chicago for some reason. So I don't know, when I created this website, this was like the template they had, so clearly I have to update this page. But essentially what it's going to look like is kind of more like the CCP College Chem one, which I have right now. This is outdated though. But I plan to have the agenda for the week, what's going on. I plan to have a tentative syllabus. I probably will not have the full semester pulled out. This is from Sinclair, so I was able to have the whole semester. For physics, I will not have a semester already planned out. I will have maybe a few weeks, and that's what will be here in the agenda. Other than that, that's kind of about it. So again, if you click the physics There will be information you probably should know in terms of, hey, here's what's going on this week. Hey, here's what you missed last week. Hey, here's what's coming up in the following week kind of information. All right, but let's go to Moodle. You already know how to log in. That's great. But I do want to show you some ins and outs of Moodle that are kind of important. So let's log in. I have to log in as me because I want to show you some kind of, I don't want to say hard to use feature, but you definitely need a tutorial. Okay, here we go. Down to Physics 1. So we'll have the welcome. It'll say Summer Assignment 1. There used to be 2 parts to the summer assignment. Now we're only doing the 1. So it's a lot of, learning about manipulating equations. It's also about sig figs. Significant figures are so important in physics. Okay, in chemistry we touch and go on them, touch and go. But because physics is pretty much all math, you must know your significant figures inside and out. You have to know how to use them in math. It's so vital. Metric conversions is kind of big. Trigonometry is huge. We are going to turn anything and everything into a right triangle. I don't care what it is. It could be a 0-dimensional dot. I will make that a right triangle. Okay, we will use trigonometry, SOHCAHTOA, until, I don't know. I can't think of an analogy right now. But just to go over something real quick. So on the very first assignment, you have to manipulate equations. And you notice I have like these fraction steps. I'll teach you how to create these fraction symbols. I'll teach you how to put in this squared symbol, although when you do it for fraction, it's a lot harder than it looks. So let me go to, oh, just FYI, when you do assignments, you'll see a thing down here that says add submission. Mine doesn't because I'm the grader, but on yours, you'll have an option that says click and it'll say add submission. Once you click it, you can start typing away. What's important to understand is once you send your assignment, you're done with it. You cannot go back and re-edit it. Once it's sent, it is sent. Now, I can change that feature. I just don't feel like changing it. So let's go to announcements where I can type some stuff. Okay, let me just blah, 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 right there. Here we go. So here's where if you did an assignment, you had to type in answers like 1, and then the answer to number 1. Answer, blah, 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 blah. So let's just go over some things that are right here. I'm going to start over here on this side and then work my way across. Here you can add an attachment if maybe you did something on a file, like a Word document or something, you can add an attachment. This you can insert a video clip. This lets you insert an image. These links let you, this one breaks a link, this one inserts a link. So for example, if I said click here, and I wanted here to click to a website, I highlight it, and then click that, and then type in the website, and then once I do that, if I click the word here, it'll send me to that website. Odds are you're not going to use these. Clearly not what I wanted to do, there we go. These are your bullets, so either you can have a dot for a bullet or you can have a number for a bullet, regardless, okay? Italics, bold, pretty obvious here. So, I mean, that's pretty clear what those do. This lets you change the size of the font. Okay, lame, cool, whatever. Heading, well, let's just say paragraph, okay? This is the main feature right here. It doesn't matter whether you're using a Macintosh, well, they don't call them Macs, wow, they call them Apples now, an Apple computer or a Windows computer. Once you click this, here's where you have a lot of options. One, this shows you where the indentation takes place or the writing. So either I can alignment, is what I meant to say. You can either left align, center align, or right align. This lets you underline or cross through. Here's how you can put superscripts, which is important for exponents. So if I want to say, later we'll talk about final velocity squared, but I don't want to use final yet because I'll show you how to do it. Actually, I'll do both at the same time. We're going to start with the subscript. So in physics, we have a lot of subscripts. So for example, V stands for velocity, but a lot of times I want to talk about final velocity or initial velocity. So final velocity usually has a subscript f. So you notice how the little f goes down there. There is an equation which says that final velocity squared So if I want to put a square, I use what's called a superscript, and then I can put the square up top. Now, I really don't like how that looks, but that is how that does work. Let me go like this. I'm going to change it back to this, and then I can hit square. I just want to see something. Okay, that's a lot better. That's a lot better. I forgot to send it back. So, for example, what happened was, okay, turn my subscript on. There's my F. I got to turn it back off. Turn on superscript. Yep, that didn't work. Sometimes you just got to play around with it. So, okay, turn it off, type a letter, superscript, squared, go back, boom. Now it looks like how I want it to look. So that would say final velocity squared. If I just want to have something squared, like let's say it's math class, x squared, just type x, superscript, squared, or 2, or 3, or 4, or whatever, or blah, 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 blah. So again, subscripts, superscripts. Subscripts for letters you want to go on the bottom and numbers you want to go on the bottom. Turn it off, make it go back to normal. Superscript, you can make it go up top. And then if you want the superscript right after a subscript, type something in and then delete it, and boom, it goes like that. Okay, cool, cool. In physics, we use a lot, I do mean a lot, of Greek letters. So this Greek letter right here, this is actually omega. This is kind of like the quick key. This is like the shortcut to get to all the different Greek letters. So one we use a lot is sigma, which stands for the sum of. Another one that's really popular when we get to Unit 4, which is force, is the coefficient of friction, which is mu, which if I can find that real quick right here, that's a very common one we'll use all the time. So to get to those, again, I just click this omega symbol, and that has all these different things. I can put arrows in there if I want to do math terms like less than or equal to, greater than or equal to, plus or minus, etc. Because plus or minus is important when we do the quadratic formula. Yeah, you need to know the quadratic formula. It's not in the summer assignments. Don't worry, don't have to memorize yet. Although if you memorize it sooner rather than later, that would be awesome. But we will do the quadratic formula in Unit 1. The hard part and the tricky part that I'm going to spend a lot of time on here, because I'm already at 12 minutes, that's crazy, is this button right here. It kind of has the square root of a. So this has a lot of the math characters. It has the arrows. It has the Greek symbols. The important ones are in this advanced area. Now, a lot of these you will not use, but you may need to write a fraction, or you may need to write a square root. Okay, these are the two main ones. So if I wanted to write the square root of something, one, you don't want this, and it kind of gives you down here, it gives you a preview of what it looks like. You don't want this A, so be careful what you delete. We want to delete the bracket A, so it just has that. And then you can type in whatever you want. It doesn't have to be BC. I'm just typing the square root of 24. So if you look down here, it shows you what it's going to look like. So I'm going to hit Save Equation. Now, you're like, wait a minute. That looks like nothing with what I wrote. It's supposed to be the square root of 24. Well, once you submit it, we'll give it a second. We'll click this. You'll notice it does turn it into the right way. So it may not look like it's right when you first do it, but it is correct. That's why the preview is so important. So again, we're going to click here for more buttons. Click the square root of A, and it's under the advances all these equations. If we want to do fractions, again, the A will be the numerator. So let's do 3 over, BC can be whatever. So let's say x. So it's 3 over x. Now, how do I do this 3 over x squared? Well, I figured this out. It took a little bit of time. But if we actually type in x caret 2, it will make it x squared down there. Okay, so that's how you add an exponent for this, because there's no superscript or subscript you can type on for this area. So if you want to do squares, if you want to do exponents, you got to use that little caret symbol, and they'll magically put it down there correctly for you. So if I actually save equation, again, it looks like jibber jabber, but once I actually send it, if I submit this, you can see it turns out correct. So that's very, 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 very important when you do the very first assignment for the equation manipulation. You have to know how to use this. So you may want to play around with it, but you're going, but Mr. Osborne, if I send it, if I play around and I send it, how do I know it looked right? Good point, good point. Make sure you use that preview. Make sure you use preview. Let me edit this. So I also want to show you, what was I going to show you? I'll just make one up real quick. Oh, I know what I was going to do. How do I get the Greek letters in there? Because I can't go back to that. So let's say I want to do all symbols, like the square root of, because physics is a lot of manipulating equations with no numbers. It's just constantly moving letters all around using algebra rules. Let's say I want to do mass times gravity times radius times position, Greek symbols. Do they have a delta? I wonder if they have delta. I don't see delta anywhere. But they do have the coefficient of friction somewhere. Here it is. This is an important one. So again, if I look down there, you can see that it is down there. That Greek letter symbol mu. I really wish they had the triangle. Oh, they do. Okay, that's great. So now I can do delta right there. Oh, that looks weird. I don't like that. Hold on. I might have to play around with this. I've never tried this part before. But delta x, which actually stands for displacement, is an important one. But I don't know how to type that in there. But regardless, so that's what you'd have to do. If you need to add Greek letters, simply just go back. Delete this. Start your equation. If you need to write a fraction or, not fraction, wow, a square root or a fraction, just click Greek symbols and you can add some Greek symbols. Again, it doesn't have all of them. It has a couple of them, but I'll make sure it has the ones you need. I will never ask you something that you cannot do. We will never use this symbol. We'll never use these. These are for calculus. Never going to use that stuff. The two big ones are square roots and fractions. And again, the fraction one's the easiest one. We won't use square root too often. It's the fraction one that's the main one. And again, and you look at the preview to help you out. The A is the numerator part. So again, you can put numbers here and letters. It pops up there. The B plus C is the denominator. And again, you can do it. You can put blah, 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 blah. And I'll put times blah, 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 blah. So it has, like, I can do multiplication there, or I'll put a minus sign in instead. So that's kind of how do you use that. Cool. Okay. Hopefully there's no more questions on that. We're almost at 20 minutes. I want to keep this under 20. Leave page. I gotta delete this thing. Delete. Yes, continue. Okay. The last thing I want to show you is, so another important part of physics is I have my favorite teacher who teaches physics. He's up in Michigan, Mr. Palmer, Thomas Palmer. Anyways, he has a series called Flipping Physics, where he teaches physics, and you'll see him during during the summer assignment in various videos. And you can definitely tell his beginning videos because you'll notice he looks up like he's reading a script. And then as the year progresses, you'll notice his hair gets longer, and his video production gets way, way, way better. But anyways, so I'm going to tell you guys, hey, you have to watch all these videos by a certain date. So for example, when we get to reference frame, there are 17 minutes and 32 seconds of videos about reference frame. Now you can't see this on your end, this is my version. But you would have to watch these 3 videos about reference frame before we cover reference frame in class. And there will be a set of questions down here. I have not created the questions yet, but what they're going to be is it's going to be about 10 multiple choice questions. 4 of the multiple choice questions are going to be super easy, where as long as you watch the videos, you should definitely know the answer. Like, it's going to be obvious if you didn't watch the videos because you'll miss them. The other 4 questions are going to be able to ask, can you apply what you learned in the videos? So for example, if he does a certain equation in the video, I may have you use that same equation. I'll just give you different numbers. It's an application. And then the other two questions will be much, much, much tougher. You really have to understand what was in the videos to kind of answer them. You really have to think outside the box to answer them. So that's kind of how it works. Now, I'm going to give you, I should give you plenty of time to watch these videos because some of them are kind of short. 17 minutes. My God, this video right here is longer than 17 minutes. But some of the sections, this one's 18 minutes. This section, part 3 of Unit 1, is 39 minutes of videos you have to watch. 25. Where's the graphing? The graphing one. It's 78 minutes, 42 seconds. So that's over an hour of videos you need to watch before we talk about graphing. But again, I'll give you probably a week of heads up before, at least a week of heads up before we cover graphing motion. But you have to watch these videos to answer questions, because basically what happens is the questions that go with the video, I will close that out the day before we cover the material in class. Okay, so again, you have to be able to watch these videos and answer those 10 multiple choice questions before class begins. It may not be multiple choice, it may just be typing, but it'll probably be roughly 10 questions. It should not be more than 10 questions. But that's how it works. Because again, these videos, I'm telling you right now, if you actually watch them and pay attention, Mr. Palmer is probably the greatest teacher of physics I have ever seen. He makes this so simplistic. I mean, I was very confident that if my AP students watch this, they would do extremely well. We started watching them a couple years ago, and they were very, very helpful. The problem was we didn't start watching them until the very end of the school year when I discovered them. But there you go. So that's physics in a nutshell. Again, this is kind of a long video, but hey, it's a long introduction. So there you go. Thanks for joining the class. How do I turn this off? Oh, there it is.